So we're doing task 1, check condition and concentration of coolant. The first thing we want to do is note down the information for vehicle 1 and for vehicle 2. We want to put in their VIN number, year, make, and model for both, because we're going to need especially this information a little bit later on in this activity. The next thing we have here is our objective. Students will check condition of coolant, determine concentration, condition, boiling and freezing points, and make recommendations as needed to bring coolant up to factory specifications. And then our materials here, our protection, again, of course you have your safety glasses on, our hydrometer, coolant tester, and then your 2 vehicles that will be assigned to you. Now the procedure with engine cool, we're only doing this in this lab with the engine cool. We want to make sure that it's cool before we start. We want to touch that radiator cap and make sure it's not warm or hot. If it's warm or hot, we don't touch it until it cools down. Your car should be cool, but always want to make sure and double check before just opening that radiator cap up. The next thing we want to do using our coolant tester, draw out enough coolant to fill it to the top of the fill line. Now, in the hydrometer video, we demonstrated how to do this and how to use this hydrometer. You're going to use it the same way. You want to fill it up to that top fill line and then take a look at it. Just note the boiling point, and again that's going to be on one side, and also the freezing point, that's going to be on the other side. And you're going to note that down here for boiling point and here for freezing point. Just note that we're measuring this in Fahrenheit. It does list Fahrenheit and Celsius. You got to make sure you're writing down the right number here, and make sure it's a Fahrenheit for all of these. We're not measuring things in Celsius right now. If we're in physics, we might do that, but for this, we're just doing this in Fahrenheit. The other thing we want to do is note the appearance. Here for vehicle 1, vehicle 2, here's some examples. What color is it? Is it clean? Is it dirty? Is it contaminated? Is it all water? Take a look at the consistency and note this down here for 1 and 2 here. The next thing we want to do is note our recommendation. Now, do we want to flush a system, meaning does it need to be changed? Or is there no service required? Everything is wonderful. The boiling point, freezing point are good. The appearance is good. That would be no service required. If our boiling point or freezing point was off, or if it was dirty or contaminated, we would want to flush the system here. So we want to know which one, and then you're going to explain why you chose flush system or no service required here for vehicle 1 and vehicle 2. The last part of this is looking at the total cooling system capacity. How much coolant is this engine or this cooling system going to take? And we're going to need to get on Identifix and look that up. How we would do that, get it on Identifix and type in a year, make, model of car, and go to the same section that we've been using in Identifix. We can note how many quarts are going to go for vehicle 1 and for vehicle 2. The second part of this is how many quarts of pure coolant do you need to make a 50-50 mixture, and then we're going to note that here. And again, to make a 50-50 mixture, we're adding 50% coolant to 50% water to give us our mixture, which would be this amount here. So you need to do some math here to figure this out. And then the last question here, we've already gone over this, but why should you only open the radiator cap when the engine is cool? This is super important to know this answer. You have to be very careful when we're working with cooling systems and be able to answer this correctly. So once you've completed all that, bring it over and we'll check it out and get you signed off. Okay, so we're looking at our hydrometer here for lab 1. We're just going to take a look and see how this works. Look at some numbers on here first. On this side, this is our freeze point right here. And we have some numbers here in Celsius and Fahrenheit. And depending on the condition of the coolant, this arrow will line up with one of these sets of numbers. We want to use this Fahrenheit number and use this lower set of numbers here, not the Celsius for the time being. Also, 50% concentration recommended. That has to do with mixing our coolant to water 50-50, and when we do that, we should achieve negative 34 degrees Fahrenheit if we've done it correctly. Now, if you flip this around on this side, this is our boiling point protection, and what we've got here again is our boiling point in Celsius on top, in Fahrenheit on the bottom, and then again, what's our 50% concentration when we mix the coolant to water? That should give us 265 degrees Fahrenheit boiling protection. Okay, so what we're going to do, we're going to bring this over to our coolant. So we just have this bowl here right now, and we're going to squeeze the bowl, and we're going to draw the coolant up into the tester. And I put a little bit too much on the squeeze, a little bit out, and that's pretty good. And we want to fill it up to the fill line right here. It's kind of hard to see, but that's our fill line, and then you can stop, and then we want to look to where our pointer is pointing to. Now, you want to make sure we're holding it straight up and down. We're not tilting this one way or tilting it the other way. That's going to give us a false reading with our arrow here. So we're at about 260 degrees boiling point right here. If we flip this around, we are at about -7 for our freeze point right here. Okay, so you want to note that, you want to write that down in your lab packet, what you actually got, depending on what I have set up, whether I have a bowl like this, or if I give you a card that you're going to do, you want to write that down. It may not be this 34 degrees Fahrenheit, and that's fine. You just need to note what you actually found when you tested the coolant. And once you're done, go ahead and squeeze this back into the bowl, and then go ahead and wash it out. Okay, just take it over the sink and rinse this out, and you should be good. Okay, and that'll complete this lab.